Hello everyone, this is Vipul Purohit and I welcome you all to my YouTube channel. My dear friends, as you can see over here, this is the fourth part of Oxidation Reduction Chemistry. The first three parts I hope you have seen. In the first part, the basic terminologies. In part 2, the Daniell scale and the redox reactions involved in the Daniell scale. In part 3, the balancing of a redox reaction using ion electron method. Now this is part 4, my dear friends, and as you can see that here in this particular session we are going to discuss about Latimer diagram. Yes, my dear friends, it's Latimer diagram. So first of all it's going to be an introduction only. It's not going to be in a much more deeper level, my dear friends. It's just an introduction. And what I'm going to consider in this introduction is, पहले Latimer diagram होता क्या है? What is Latimer diagram? And then I'll explain you with the help of one example. Alright? So here we go, my dear friends. Latimer diagram is the simple representation. It's the most easiest representation. Representation of what? That's the question. What it is going to represent? Yes, the answer is stepwise half cell reactions, which we call it as HCR. You guys know very well about half cell reactions. I've been explaining this concept in the previous three parts as well. So you know what is half cell reactions. So stepwise half cell reactions को represent करने के लिए हमने Latimer diagram use करते हैं. उसे हम connect करते हैं with the various oxidation states of the species involved in that particular half cell reactions. Various oxidation states of the species involved. Okay, और उसको फिर हम connect करते हैं. We are also connecting this with the SRP values, standard reduction potential values for a half cell reduction reaction. For a half cell reduction reaction. Yes, my dear friends. So this is the simplest way of defining what is a Latimer diagram. Okay, once again I repeat. What is a Latimer diagram? Is the simplest form of representation of the stepwise half cell reactions which are being connected with the various oxidation states of the species which are being involved in that half cell reaction, and that is being connected with the SRP, that is the standard reduction potentials of the half cell reduction reaction. So यहाँ पे दोस्तों हमें reduction reaction consider करना है, और reduction reaction consider करेंगे तो हम उसका SRP values find out करेंगे. उसे हम जोड़ेंगे किसके साथ? The various oxidation states, और इस तरीके से stepwise half cell reactions के बारे में हम बात कर सकते हैं. So please have a look at it, my dear friends. Have you all understood up to this? Alright, my dear friends. Now once you have understood what exactly is Latimer diagram, as I said, I'm going to give you an example of this Latimer diagram so that you understand the concept very well. And I'm going to give an example of ion in acidic medium. So first of all, I'll explain you in the tabular format. And that is the half cell reaction as the first column. The second column that we are going to discuss about, and that is about the E0 values. That is, of course, it is the SRP values. And then we will be also talking about delta G0, which the formula of which is minus of NF E0. Okay, so this is what we are going to consider. So we start with the first reaction, my dear friends. The very first reaction is all about Fe in the 3+ state gains an electron, it gives you Fe2+. The E0 value for this is plus 0.771 volt. Now if you want to go for the delta G0 over here, so that is minus of N. N means it stands for the number of electron, which is 1. F, we'll just keep it as 1F F value is 96,500, but for simplicity we'll give it like this. And then it is going to be 0.771 volt. So that is equal to minus of 0.771 F volt. Okay, this becomes your first part. We go into the second reaction now. Fe2 plus will gain 2 electrons and it will give you Fe. The value over here is minus of 0.441. So here we have minus of 2F into 0.441 V. So that is equal to minus of 0.882 FV. Okay, this is delta G naught. And we come to the last one now, and that is Fe3 plus 3 electrons gives you Fe, question mark. So on the basis of these two data, you are supposed to find out E naught. And once you get E naught, you can easily find out delta G naught, isn't it? Because you know the value of N. How many electrons are involved? 3. F 96,500, which we keep it as it is for simplicity purpose. So only what we require is what? E naught. Okay? So we are going to find out that. So in the form of Latimer diagram, as I said, it's the simplest way by means of an arrow of representing the stepwise. These are all the stepwise half cell reactions. Alright? So we begin with, we talk about Fe, Fe2 plus, Fe3 plus. Alright? This is the way we are going to discuss about. So now, when you talk about Fe3 plus to Fe2 plus, I can make it like this as well. Fe3 plus to Fe2 plus, Fe2 plus to Fe. This way also it can be done. So 3 plus to 2 plus, the value is, E naught value is 0.771 volt. Fe2 plus to Fe gives you E naught as minus of 0.441 volt. We can make it as this as E2 naught, we can make this as E1 naught. Okay? And now Fe3 plus to Fe, it's a question mark. Okay, that is what we call it as E3 naught is question mark. So that is what we need to find out. So the formula for this is E3 naught will be equal to N1 E1 naught plus N2 E2 naught divided by N1 plus N2. Now what is here? N1 is 1. That is this reaction I am talking about, 1 electron. N2 is equal to 2. 2 electrons are involved. Okay, so you use this particular formula. So we have 1 into 0.771 plus 2 into minus of 0.441 divided by 1 plus 2. So that is giving me 0.771 minus of 0.882 divided by 3. So that is going to give me minus of 0.036 volts. And if you want to go for delta G naught, so delta G naught is equal to, this is minus, this is also minus. Okay, here I'll just make it a correction, it's minus, so overall it becomes plus. So here also it becomes overall plus. So we have plus 0.036 into 3F. So that is equal to plus 0.109 FV. Okay, this is what we get as delta G naught. So this is the E naught value which we get, and this is the delta G naught value we get. So you can check it out now over here. On the basis of Latimer diagram, this is what the Latimer diagram is all about. Above the arrow, we are going to write down the values of the SRB. Okay, and then we are going to connect it with the stepwise half cell reactions. And also you can see that the connection is with the various oxidation state. That is what Latimer diagram is, which I've explained to you a few minutes back. And then on the basis of these two data, we are in a situation to find out the value of E naught. And once the value of E naught is being found out, we substitute in this equation, we get delta G naught. Now from the values of E naught as well as delta G naught, we can also find out that which reaction is favorable. Okay, if I write down this is as reaction 1, reaction 2 and reaction 3. What are the conditions for favorability? And that is, the condition is very simple. Delta G naught is to be negative and delta E naught has to be positive. This is the condition, my dear friends, for favorable reaction. This is a condition for favorable reaction. Alright? Or we say the reaction has to be what? Spontaneous. We need to have delta G naught. I write down very clearly so you understand this. Is delta G naught is negative and delta E naught has to be what? Positive. So from this, what we can conclude is, in the first case, that is conversion of Fe3 plus to Fe2 plus, delta G naught is negative, E naught is positive, so yes, this is a favorable reaction. Okay, that is gain of an electron by a ferric ion resulting in the formation of a ferrous ion is going to be a favorable reaction. If you go into the second reaction, that is a ferrous ion is going to gain 2 electrons to form an ion atom. E naught is going to be negative and delta G naught is positive. No, it's not possible. So cross mark. Now the third one, ferric ions gaining 3 electrons to give you an ion atom. Now here in this case, E naught is negative and delta G naught is positive. So once again, it's not being favorable. So the second and the third reaction is not favorable, my dear friends. Only the first reaction is favorable, which has delta G naught as negative and E naught as positive. Alright, so this is the simple example of a Latimer diagram so that you can understand what Latimer diagram is all about. It's the simplest way of representing the stepwise half-cell reactions. They are going to involve over here the oxidation state, the various oxidation state of the elements. And with that, they are also going to involve the SRP values, that is the standard reduction potential values. And also, I went a step ahead, and that is, once I know the standard reduction potential values, I can also comment on the delta G naught value. And on the basis of delta G naught and E naught values, I am in a position to find out whether a particular reaction is favorable or not. Alright, so this is the basics of Latimer diagram, my dear friends, and I am very sure you must have all understood this very well.